Wait a minute. Oh, hello. All right, welcome back to another installment of Monty's Python Show. Today's video is going to be about using the raise keyword to raise exceptions in Python, how you use it, and what are the scenarios in which it might be helpful. So we want to start off with what is the rationale for using the raise keyword to raise an exception. The first thing is you might want to create a custom error message. Okay, let's take a quick look at an example showing you how to use the raise keyword and a custom error message to make your error handling more useful and more customized. If you look at the code that we have here, there is a function defined called withdraw money, and it has two parameters, a balance and an amount. And in the function, it does a simple check to see if the amount is greater than the balance. So if that is true, this code will raise the value error and it will pass the custom message, insufficient funds, cannot withdraw amount, only balance available. And we've got, so we'll raise that inside the function. And you can see down below here, we're calling the function from inside of this try block, and we're going to try and catch the value error as E and print out its message. So I'm gonna go ahead and run this code. And you can see down here in the console, the outcome, it printed this custom message, insufficient funds, cannot withdraw 150, only 100 available. Rationale number two is data validation. Okay, so in this example, here's a function called check temperature, and it checks to see if temp is less than negative 273.15. And if it is, it will raise a value error and print out the message, invalid temperature, temperature cannot be below absolute zero. So we're just validating that the input to the function is correct by using an error handling framework. So down below you see I'm calling the function with negative 300 as the argument inside of a try except, and we're going to catch that value error that we're raising here in our except block and print out the message. So you can see in my console we've validated that this data, the input that we've used for temperature is wrong as it is below absolute zero. Okay, now the third reason to use raise to raise an exception is to add flexibility and control in your programs. Let's take a look at an example. Okay, so in this example we have a function called process file, which is going to try to open up a file, read the contents, and then return it to the function call. And if you look at the except block that's inside of this, inside of the function definition, you'll see that it doesn't handle the exception file not found error other than to raise that error. And so what that does is that allows the function, or excuse me, the exception to propagate back up to the function call so that you can determine at the level of calling the function how you want to handle the error. So you can see down below where we're calling the function inside of the try block. This is where I'm determining how I want to handle the error. So I'm leaving the error handling to occur externally from the function in this example. So we'll go ahead and run this, and you can see that it prints the message caught in the caller, no such file or directory, non-existent file.txt, and that is being handled here in my try except block and not inside of my function. So this raise keyword allows the exception to propagate back up the call stack to where the function is called, and we can handle it there. And you'll see an example of this in a little bit that will make this this type of situation a little more clear. Okay, I want to dig in a little bit more to using the raise keyword without any specific exception, which has the effect of re-raising an existing exception. So when you use the raise keyword by itself, it just re-raises the current exception. So that implies that there is an active exception that is being handled or has been caught. And so for that to be true, this must be done inside of an except branch relating to the try branch that experienced the exception. So you might be wondering, but why would you do this? What is the point of the original error handling if you're just going to raise the same error and then not have it be handled? So what is the point of the error handling? It just results in the same exception. Okay, take a look at this file. So this is an example of a function that is defined called divide numbers, and it's a simple function. It takes two parameters, it divides A by B, and then inside of a try block. And if there's an exception, it will write the exception note to a text file called log.txt. If there is no exception, then the function just returns the result. So down below here, inside of the name equals main idiom, I am printing out the function call with the parameters 5 and 8. And so if I run this code, you'll see down below that it returns the value of 0.625. Okay, so in this particular case, the exception handling did not come into play. Now let's run this again. Let's change the 8 to 0 and see what happens. I'm going to run this. And so now you can see what happened was an exception was raised. The error was written to the log.txt file. And so here's what the log.txt file looks like. It just has one entry with that error in it. Nothing was returned from the function, so it printed out none. Okay, so that's all well and good. Now here's why it's useful. The exception is not being re-raised. It is just being raised upon the try, and then it's being handled in the exception block. Okay, so now let's extend this analysis a little bit. Let's suppose that this function divide numbers is actually going to be imported into a different Python file, and this file is going to be used as a module. So let's switch over to this different Python file. Here I'm importing that function divide numbers from the file module into main.py, and I'm calling the function. And I'm passing the arguments a and b, which are set equal to 5 and 0. So let's go ahead and run this code and see what happens. So in this case, when I'm importing the function from the using that file as a module, I don't have any transparency as to what actually happened. All I know is I tried to call the function and I got none back. And that's because the exception that occurred from dividing 5 by 0 was handled inside of module.py, and I never got any information about it. Now, it is true that the log file, log.txt, has that error in it, but as far as my programming in main.py, my program isn't aware that it actually passed an improper value to the divide numbers function. So now let's change this file, module.py. Let's add the raise keyword inside of the except branch, like this. And we'll save this. And now I'm going to go back over to main.py and run my file. So now the division by 0 error was allowed to propagate over into my main.py. So I can log that information over in module.py, and I have transparency as to what happened in terms of what the error was, so that I can have proper error handling inside of my main.py. So now I can change this to using a try except framework to handle this error. I'm just giving it something simple just for now. Okay, so now I have more useful information about what's going on with my project, because in module.py I used the raise keyword to re-raise the exception and allow that exception to propagate back through module.py into my function call, which is occurring over here in main.py. All right, so that'll do it for this episode of Monty's Python Show. Hopefully this was helpful to help you really understand how to use the raise keyword in Python and what some of the typical use cases are for using it. Until next time, keep the crumbs out your beard and Python.